Welcome to Dartisans. Today we're going to have web components reloaded.
Oh man, this is good stuff.
We have Dimitri Glazkov. Is that the proper pronunciation?
As good as it gets.
Now, you're like the grandfather of web components. Does that mean like the kind of grandfather that like when you baptize someone, or the kind of grandfather who carries a gun?
I'm more like an uncle, actually. I
An
take
uncle?
something that somebody was raised those components a long time ago, and I'm just trying to take care of them as best
Is
as
that
I
right?
can. You know that movie, John Candy. You know.
You got to take care, cherish the web components.
Exactly.
You know, the future is a delicate thing, and we have to make it happen gently.
Right. I like it.
Yeah,
I like
awesome.
where this vibe is going.
So later in the show, we're going to have John Messerly and Siggi Cherem, and they're going to talk about Dart web components. And so this is a twofer. I'm super excited. This is like, you know, a lot of effort went into this show. I'm super excited about this. So why don't you get us started and tell us what these web components things are?
I'm also super excited, by the way, just not to be outdone. So web components is really an umbrella term for a bunch of things that are happening in the web platform to kind of make things normal for web developers. This work is being done in the World Wide Web Consortium Web Apps Working Group, and Chrome has bits that have landed and are running right now. And Mozilla is landing some bits, Microsoft and Opera are participating. So this is kind of like a broad effort, and we're trying to go and take our time and make sure we get this right. So this is where you guys are going to be really important. Please listen to this, identify the points that seem weird and talk to us, because this better be done right. So why are we doing this whole thing? The interesting thing is that, as you may have found out, the web apps are for real. So people write complex, big web apps. And when the web was first developed, web software engineering wasn't really a thing, because when you just want to write a few small scripts, it's not that big of a deal. You really don't need software engineering for it. But the scripts have gotten more complex, there was more stuff written, there was more and more code, and suddenly we've gotten to the point where it's like, okay, we have to figure out how to do this rationally. And the biggest problem that we found is that the web platform as we know it, really backs all the way up to the DOM. The DOM, the document.body, query element, query selector, get element by tag name, and all that stuff. All these things are the lowest level that the web developer can feel on this thing. And the problem is that some of the primitives that developers, an engineer would expect in any normal software platform are missing. If you look at this object-oriented programming, the tenets are encapsulation, inheritance, polymorphism. You can get it if you have a nice programming language, but once you get down to the platform level and start dealing with the DOM objects, those are just magic forests, and with elves and fairies, you can't figure out what the hell's going on. And you can't extend them, you can't hide things, you can't encapsulate things. And so really the choices at that point we have are either work around it or not write complex apps. So clearly, the choice of workaround seems a little bit more preferable than not writing complex apps or giving up. And so the types of workarounds you would see were, generally in two categories. Either you fight the DOM, or you build an abstraction around the DOM, like jQuery is a really good example, right? Every object you get out of jQuery is actually a jQuery object which wraps the DOM to protect the user from the evil DOM. So you're basically actively fighting this. And then there's things like Sprout Core and Sencha and now Montage that basically say, hey dudes, we're going to build our own thing, and we're going to make our own object tree, and this object tree will magically talk to the the DOM tree and make it somehow work, and you just don't worry, you're pretty head about this. And the other one is, of course, screw the DOM, right? You basically say, oh, canvas, awesome. Okay, I'm just going to draw my entire thing on canvas, and everything's going to just work. The problem here is that you still will need an object tree. You'll still need to handle accessibility. You'll still need to handle things like selection and and BiDi support, right? And at that point, once you've handled all those things, you've written a rendering engine.
Yeah.
That is a lot of JavaScript code that has to come load and all this stuff. So all these workarounds are kind of sad. And what I wanted to do when I came in, I was a web developer for about 15 years before I started working on this, is I said, I don't want to be sad. I want to be happy. Happy is like my middle name. It's Dimitri Happy Glazkov, by the way. And so what I said is like, dudes, let's fix this. Let's figure out a way of how we're going to make this work in the platform so that you don't have to fight the DOM and you don't have to build your own rendering engine to get good results, so that you would actually enjoy the DOM. And so what we kind of figured out is that let's take those tenets of object-oriented programming and let's figure out how we can naturally, organically, that's the key word, right? Green, organic, no pesticides. We applied them inside of the existing system, which means that we use the DOM, we just tweak the DOM to allow these wonderful principles. So for example, for encapsulation, we invented Shadow DOM. We didn't really invent it. It was invented a long time ago by a lot of people. There's people from Microsoft who came up with a bunch of crazy ideas that were really good at some point related to HTC. And I don't know if you're familiar with behaviors, the HTML behaviors. There's Mozilla that has XBL and all of those things. And SVG even has its own version of Shadow DOM. And so the Shadow DOM basically says this: look, dudes, we will make sure that the developer of whatever widget is being developed, let's call this developer Bob the builder, right? Does not have to worry about what the consumer of this widget, let's call him, in best traditions of Minecraft, let's call him Steve, right? Steve does not have to, worry what Bob built, and Steve can't screw things up. Does that make sense?
Yeah.
And so if you kind of look at the encapsulation, there's like two things in there. First, Bob wants to defend against Steve. Bob built the widget. He doesn't want Steve to come in and muck with it. And then at the same time, Steve wants to say, oh, I have this widget from Bob, and now I want to be using it reliably without it breaking apart at some point and stuff starting to spill out from it. And suddenly all my, things, I change the style and suddenly everything is green there. I don't know why. Something happened. And so that's what encapsulation is about. And generally, if you kind of think about it, is we give Steve, the user of the widget, their own document tree, and we give Bob their own widget tree. And so they can work inside of the tree and not have to worry. We will be the encapsulation boundary inside of this thing. And so that's what Shadow DOM really is about. And the second one, we looked and said, well, inheritance seems nice. Every programming language in some shape or form has inheritance. But again, once you back up into the DOM, there's no inheritance. There's just things, and those things are there. HTML development. Grr. What if I want to build my own thing? What if I want to inherit from that? You can't, right? So what we decided is we're going to let you do that. And that's what custom DOM elements do. They essentially allow you to take any DOM object and say, well, I want to build my own type of thing that's just like that and inherit from that. And so it's like, if you kind of listen to this and you've never built web apps before, you keep going, what the hell? What are they talking about? And the web developers are going, yep, that makes sense.
Yep.
No, it doesn't make sense. All of these things should have been there in the beginning, and they weren't. And so now we have to kind of retrofit them to make them work. And finally, the last bit that's really important is this simple principle that you should be able to take a chunk of DOM and define it in some declarative fashion and then use it later. Oh my God! New concept, right? No, not a new concept. Very simple thing. Why can't you have that? And so the basic idea is that you should be able to use what's called HTML templates, and you can just specify and say, this thing I'm going to use later. Don't render it. Don't load images. Don't fetch resources. I'm going to use it later. Just hang on. And then the other thing is it's obviously declarative syntax, so you can just write it as HTML. And in addition to that, we're adding this cool feature called packaging, which means that instead of just being able to include just JavaScript into your page, you can include something that's called a package or link rel components. And you link to an HTML file, and then the browser can then suck in all the resources from it, like CSS, JavaScript, and markup, and all those things into one thing. So woohoo, this is amazing, right? It seems like such an amazing breakthrough to web developers. Again, to non-web developers, it's like, what the hell? Why didn't you have this before, right?
Yeah.
And so if you want to learn more about it, just go to Google+ and search for web components. There's like a page that tracks all the latest presentations. There's a bunch of them out there. Some of them are really, really awesome.
I liked your Google I/O presentation, by the way. That was pretty good.
Right.
And then there's also the Web Components Explainer. That's all. When I search for that, it always comes up with the document, which is actually really easy to read, unlike a lot of specifications.
Yep. And so try not to get drowned in the specs, because those are really technical language things that were primarily written not for you. They were primarily written for the engineers who build browsers, so that we can assure that whoever builds this thing into the browser does it the same way that the other guy did.
Yep.
And so we just have to make sure this is specified right. So, please dig in and look at those things. And now I'm going to hand it off to these wonderful folks that are around here.
So I'm just curious, now that we're going to implement all the interesting normal things that we have in programming languages. We're going to have encapsulation. We're going to have inheritance. What other cool things can we steal from programming languages? It's like,
we just need to keep stealing stuff, right?
Yeah, I think that we just need to read some papers back from MIT AI Lab in the 70s, and every time we see something interesting, we'll just steal it and shove it in the browser.
It's really surprising, because in a lot of sense, the libraries that I was just disparaging for how they're working around things are a huge informer in this whole process.
Yeah.
Because by reading those libraries and understanding what trouble they're encountering and what the length they have to go into to make things work is what informs the spec and what says, oh, we can fix this.
So to what degree would you say AngularJS fed into Web Components?
We actually talked to AngularJS folks a lot. They have influenced a lot of the early decisions and a lot of general thinking. It was really cool, and they have to again fight those battles, and the design decisions they make are heavily influenced by what's really possible.
Yeah.
Whereas we kind of have this cool ability. We can say, hey, we're the browser people. We can make it work.
Yeah, if only we knew someone who worked at a browser. Oh, wait, we
exactly.
do.
Exactly.
So I know that model-driven views are not really I don't remember reading any about them in the Web Components spec, but it seems like Web Components is this umbrella term that has come to encompass model-driven views in the same way that we use HTML5 for a bunch of different APIs. What do you have to say about that? It seems like MDV is important these days.
Model-driven views is simply, again, rationalizing the patterns that we've seen so many times. I mean, so many libraries out there are embracing templating patterns. The Mustache, the Ember.js, all these guys are looking at this idea that you should be able to declare stuff and then put in the holes in and then run it against some sort of a data set, and suddenly, boom, things go live.
Yeah.
It seems what? This is Mr. Obvious, this is very simple. But what we're trying with MDV to do is we're trying to first concentrate on what are the things that are truly missing from the platform that don't let you this nice ability to do this type of data binding. And there's two things that are really exciting. The observation-related things, right? If you want to be able to bind to data, you have to be able to first observe what DOM objects are doing. You have to say, hey, this thing changed. I better react to it somehow. And this is where, we used to have a thing called the mutation events.
Yeah.
Nasty thing, because first of all, mutation events are really slow. They're synchronous. And they are the wrong thing, because in a typical web application, the DOM tree changes a lot. And that results in a lot of mutation events. And instead, we came up with this whole new abstraction called mutation observers. And those are a much more elegant designed thing that's specifically aimed at solving the problem of observing DOM changes.
Yep.
And then you look at the opposite and say, hey, now I want to be able to look at the objects, the data objects, and when they change, I want to be able to know about it.
So this is a big deal in terms of performance, because I've seen some graphs where if you have to do dirty checking, which is what you have to do today, versus having it built into the platform, the performance differences are amazing.
Absolutely. Yes.
Yeah,
it's crazy, 20 to 40% time.
Not 20 to 40%, but 20 to
time.
40
I almost said
times
percent.
faster.
It's because it doesn't even come out right.
It is
times.
Times faster.
And
that enables a new type of application when you can do
right.
that. So I know that one of our questions, I skimmed through them really quickly, but I think one of them one would be good for you. And he was asking, what is the benefit of including this in the browser instead of just relying on more, libraries to provide this for us? And we just talked about the performance benefits, but can you think of other benefits? Why do we want this in the browser?
Well, performance, leaky abstractions, and just generally painless development. I don't need to include something in order to start. This is my platform, this is where I live, this is where I want to work in. And so if you say, well, my platform is not actually a web platform, it's actually Sprout Core, well, that means you're working on a different platform. So what we want to do is we want to come down to the platform level and enable as many of those features. But the most important thing is that by enabling these features in the browser, if we're doing it in a smart way, smartly, I guess that's the word, what we do is we also inform the browser a lot better about what's happening. And when we do that, we have a lot of opportunities that are still not even discovered fully of where the browser can go faster, can use less memory, and can essentially do the job better. And we can really accelerate the pace and the speed of loading, the way applications operate, and the way they fit.
Yeah, I also think that with a lot of these widget libraries, they're trying really hard, but it definitely seems like it's hard to get interoperability between these frameworks. And I definitely would love to see a point where we have, all of these rich web components, and then we could share them between libraries so that we don't have to have, we don't get into situations where I see this beautiful widget, but I can't use it because it's not using the same framework I am.
And there's actually a really interesting effort that's coming out of the Mozilla, and they're called X-Tags. They're really interested in this problem of what if we could define some way to say, this is the best practices of how to build these web components. They're not necessarily all difficult, hard rules, but just a general set of things. And if you follow those practices, all of the components are interoperable. So that's kind of a cool thing that's happening.
Great. So, I'm going to start segueing, but I got one last question for you. Having watched the Google I/O talk, your Google I/O talk, I've seen the future. How do I get there? If I want web components today and I don't want to wait because I'm impatient, what do I do? What do we do?
There's some bits of it that are in Chrome.
Okay.
Some bits of it, actually Mozilla is going to land some of these really interesting things related to custom DOM elements very soon. But there's also polyfills or shims for things that you can use. And generally, it's not 100% fidelity, but it's pretty darn good. So you can start experimenting with this stuff.
Okay. Thank you very much. Thank you for coming and giving us
pleasure.
a great explanation. And now we're going to talk to John Messerly and Siggi Cherem. And of course, I got to ask again, did I pronounce it correctly or not?
That sounds wonderful.
I cannot hear them.
You got it. You got it.
Okay. So you guys are, where are you guys again?
We're up here in Seattle.
Okay, and I've heard rumors that in Seattle the sun is always shining because it's raining out here in Mountain View. Is this true?
It's true today, for what that's worth.
The sun, we've proven it. The sun always shines
Well,
in Seattle.
not true anymore.
Always, by a sample size of 1. So
Good enough.
I have no, I cannot hear them. So, you guys have a nice presentation. You guys are going to talk about how to do web components in Dart. Why don't you take it away?
Cool. So, basically, we're very glad that Dimitri was here and presented right before us, because we basically are working on top of a lot of the ideas that had been being developed in the standards and web community, and a lot of the work that Dimitri has been doing, and essentially adapting it to work also in Dart. Now, basically the goal here is very similar to a lot of the motivation that we heard earlier. That we want to have happy users, people that can actually get an application that runs fast, that is secure by construction, and essentially they can use great web applications. And we want developers in the process to actually be happy creating those applications. That means writing less code than what we used to, having a way of iterating quickly and somehow be able to change your code and not have to be stalled or slowed down by a huge infrastructure that essentially you have to wait on before you can actually do a change and see it immediately in the browser to see whether or not it worked. And something stable enough that you can then split the work with a lot of people, be able to have a team of 5, 10, 50 developers working together and be able to collaborate without having to do so much coordination as we have to do today.
Yeah, it gets back to the good software engineering stuff that Dimitri was alluding to earlier. So we know there have been many frameworks out there to compensate or to sort of work around the issues that we have in browsers today, and that examples of that are like AngularJS, Ember, and many more. And that motivated a lot of the work that Dimitri is doing, that of creating new web standards that incorporate a lot of these principles into the platform. So we have the standards for web components, and there's now this new sort of more experimental proposals for MDB templates as well. So what we decided to do for Dart is that we're going to embrace these proposals. We're going to take them as if they exist today. In the meantime, we're going to sort of polyfill and make sure that we can actually use them, but by embracing them, we're actually going to be with some beneficial factors in the long run.
I love this part of it because we don't have to wait for the future for web components in the Dart world. We can start using them today. That's just awesome.
Yeah, that's exactly right. So there's this term that you may have heard. I think Dimitri mentioned it, but if you haven't heard it, it's polyfill, and it's kind of this notion that the web is it's a bit rough around the edges. You're really programming for 4 to 5 major browsers just on the desktop. You've got your mobile ones, and they're all a little bit different. So you're not just programming against a system. You're programming against many systems, and there's rough edges between them. And so polyfill is this kind of spackle that you put in. You fill in the holes between browsers, and especially the good news now is that we use this term a lot. You may have heard modern browsers, but it's basically kind of an allusion to the fact that like JavaScript is fast in all the browsers now, which is important for Dart because we compile to JavaScript, and in particular IE9 is really good. So we can actually bring some of these new features and have it work on everywhere that your users will want to run their programs.
So now by embracing now these web standards, we get benefit that people like Dimitri have been working really hard in designing the system so that they take a lot into consideration all the designs of other systems like Angular and so on. Yeah. So we benefit a lot from that hard work and all the history that's behind us. At the same time, we have to adapt it to make it work in Dart, so we have opportunities to provide feedback and to make sure that it's something that is not just meant to work only in JavaScript, but also in a context that is a little bit more generic and agnostic of what language is running in. And once this actually makes it into the platform and all browsers implement it, that means that our library will basically keep reducing in size.
Yeah, it's kind of, if you haven't seen this vapor.js, you should check it out. It's pretty funny. It's basically it's a JavaScript. It's the world's smallest possible JavaScript library. 0 lines of code.
That's funny. I was code reviewing it before we did this hangout.
Yeah.
It didn't take me long.
No.
Although I was still complaining about I wanted to complain about the indentation settings.
Yeah. Yeah, and then the important point there is just that a lot of people when they choose frameworks, they look for really small, right? JavaScript libraries will frequently advertise that this library gives you all this power and only 3K. And I think that by building stuff into the browser, we can both give you tons of capabilities and eventually over time reduce the size of code you have to import.
And in general, this isn't really so much a problem in Dart anyway, because we have tree shaking and dead code elimination. So you could use whatever libraries you want to use and not worry so much about 2K of code that you're not actually using, because it'll get stripped out immediately.
Mm-hmm.
Yeah.
Right.
So what's available in web components for Dart?
So, there's basically a blend of web component features and templating features.
Okay.
And on the web component side, basically we have polyfills for a lot of things that Dimitri talked about. So there's a notion of custom elements, being able to define your own tags, and the notion of the shadow DOM. When it's actually available in a browser, we'll try to use it, but we can also polyfill and simulate those features. And things like extension and composition, so you can then inherit from other components and be able to have components that inject data that you can pass to as child elements where you use them. And on the templating side, there is the notion of data binding, conditional iterations, inlining event listeners, things that are common to templating systems and are also some of this part of what MDV is specifying. But essentially, we have adapted them to work more closely to how Dart works. And a lot of these bindings and things are expressing things in syntax that is very linked to that language. So when you put all these things together, basically we have all the tools we need to build large web applications following like very nice patterns. And if you're familiar with web development or in general application development, it's very common that you want to create some division of your application in models, views, and something else. It could be a controller or a presenter or something that would plow data through the UI and the UI changes back to your system.
That's funny. I've never heard of MV asterisk pattern.
Well, I mean,
it's whatever you want to put there.
Yeah.
I think we're pretty sympathetic to the model view model if we had to pick one. I think, but they're all different words to kind of describe that extra glue.
Mm-hmm.
Exactly. So in essence, when you think about it, you have essentially one part of your code is dedicated to just a presentation. So that's what in this diagram that we have here in this slide is just saying this is the UI. Now, whenever a user interacts with it, it starts running some code that's essentially a bunch of operations that semantically represent what you want to reflect once the user takes an action. And those operations are eventually going to change your data model. And then to close this cycle, essentially we want that as soon as a change happens in your model, we want to reflect that in the UI and end up with a consistent state in your screen. So this cycle here is something that every model view star pattern essentially tries to follow. And the difference can come in essentially how do you actually make this update from the data layer to the UI. Some people say, oh, let's do those updates using a controller. Some people would actually do basically just proactively change the things from the operations all the way directly to the UI, kind of shortcutting things. And those kind of things sometimes end up carrying a little bit of spaghetti code and making it hard to maintain. So one of the things that we really like about having templating features like data binding and all the things is that you can make the data and UI correspondence more reactive. You just have some features that allow you to say this portion of the UI is going to just simply reflect whatever the latest state of the data is. Whenever that changes, this will be automatically changed. And this automatic is essentially the notion of there will be an event and then essentially a subsequent change in the UI. Just have to make sure that those events are triggered somehow.
I really like the way that MDV fits into all of this because I remember, working my way through the Agile Web Development with Rails book, and there was this kind of thing that has been, the ugly stepchild that no one wants anymore, and that's the RJS templates. And do you guys remember this, where you would write Ruby code and it would generate JavaScript on the fly to update the UI? And I just remember going through all the exercises, and it's like if I forgot to write the right line, then I would update one part of the UI, but not update another part of the UI. And the whole thing was kind of a little bit strange to begin with because I have the server trying to, write JavaScript to update the UI. But with MDV, it's really nice. I change the data, and the UI automatically updates. I mean, this is like a big win.
Yeah, exactly. Yeah, and so another interesting part about this, and this comes in when you have components. So we've got this kind of fractal picture here, which is just shows that once you have components, you can kind of have something that completely encapsulates, its model and its view and its events, and that's really nice because now, you've raised the level of abstraction. You can program against a very rich, beautiful widget, not worry about it may have tons of internal state. And that's fine. You never have to think about that. As long as the original developer got it right, you just use it. And that's kind of an added simplicity, I think, on top of the, you still want your top-level app to have this nice structure of separating the different parts. But it's very nice to be able to have it be fully recursive like this.
Yeah, I think the recursion is a really good feature. Again, coming from the Rails world where we had model view controller, but you have one model, and you're going to generate the page using one model, one view, and one template, and then a bunch of helpers. Whereas, sometimes I would get into these widgets where I wish the widget had its own model, and it was never really kind of a first-class citizen. But with web components, each web component is, a full citizen, can have its own model. And then you could have, separate models that are the congregation or the aggregation of a bunch of other web components. And I just love this, being able to structure my app in a fractal-like way, as you say.
Right. And I think that's why we sometimes prefer these MVVM, the model view model architecture, where view model actually represents the model that is mainly associated with view pieces, and it's not so much about all the background task or synchronization of data, the stuff that you normally would push all the way to the server.
Yep.
Yeah.
Okay.
So we have a bunch of examples in essentially the articles that we publish in the dartline.org website. And we extracted a couple examples here just to highlight some of the features that we have on the templating side of things. And this first example is actually also from our website. And one of the first things that you can see is that then, let me highlight that, is what's the notion of a data binding. And in this example, you see essentially is the notion of a little piece of UI that shows a counter and a button that increments this counter. And what you see, this double braces with a count inside is saying, well, this is actually the value of the variable count. Whenever that changes, I want to reflect it here in the UI. Now, similarly, this is sort of a way of doing one edge or one of the edges on the triangle we saw earlier. Another edge is saying, well, how do I do now UI events and listen on UI events? And you can do that declarative as well. And the syntax here is very similar to how back in the day you used to have on the DOM the notion of on events in the DOM, which are typically very discouraged because you don't want to do that like right up front. But this is more okay. This is a declaration. This does not necessarily mean when it's going to run. And it has a lot of that implicitness that Dimitri was talking about templates. This is just, I'm declaring what the behavior is. Later we'll figure out how to run this code. And once we're going to run it, it just means when you click on this thing, we're going to call the method that is actually represented inside of that event handler. So in this particular example, we'll increment the count.
Yeah, I love the fact that, you update count and automatically the UI updates, but I'm going to have to say that, I really don't like the syntax of the way you have the double curly braces, and I'll tell you why. I'm a Python programmer, and I just think that braces are ugly.
No, you can import them in Python from future import braces.
Okay, so tell me about iteration.
Most decent, I guess, templating system had a way of going through the data and iterating over it or having conditionals, some notion of control flow. But it's basically just saying I want to essentially expand a section of my UI in multiple times for each one of the variables in the collection. So that's an example that you can see now. And this is from our to-do MVC example that you can also find in our private page. So basically, iteration, here's where we start doing some of the changes to make it a little bit more closer to how you write things in Dart. Saying, well, we're going to introduce here the syntax similar to how foreign looks here in Dart, even though it's actually it's the same that MDB uses for Dart templates. We just happen to match.
Yeah, and we let you use Dart expressions. So you'll note view model dot is visible. That's just Dart code.
Right.
For the binding.
So the next binding that you have under it is a conditional, saying okay, this is a template that we're only going to display if this condition is true. If it's not true, then we're not going to actually touch it. So you could in fact have expressions and bindings inside of that conditional that depend on the condition that is above it. So it's not that you have to be preventive about and null pointer reception or something of that sort.
Yeah. And the template actually, that template node, that's the thing Dimitri was alluding to earlier, where it's saying, everything under this node is inert until we do something, until there's some condition like iterate or if that causes us to care about it. And so I'll also talk about, so now we'll highlight this x2do row. And that's basically, that is a instantiation of a web component. So x2do row, of course, if you know HTML, you're like, there's no tag like that. So that's a tag we made up. We made up just for this application. And we can just use it in HTML. And this is the thing, this will work in browsers. So that is just, I want to make that point again because I think that's really exciting. And then we can do data binding with it too. So it just like we can do data binding for a normal attribute, we can do data binding of a field of our component. And we can say, hey, when you create this x-to-do row, make sure that you assign, you fill in its to-do attribute, its to-do field in Dart with the value of x.
So basically, let us show you what is to-do row, how it was written initially. But basically, when you write a component, it's similar to declaring essentially a new element in the DOM. And when you think of DOM elements, essentially they have attributes that they commonly have a corresponding property, sort of that matches the name of that particular attribute. And that's sort of what we did here. So when we're defining a component, we're saying, well, there's some fields in this component class, and one of them is the actual to-do item. That's sort of linked back to our model. When we display the view, we say, well, it's like an li element, and it has a label that says this is the task that you have to do, and so on. But what's interesting is that then the binding that we did on the previous slide was basically just saying, well, these attributes corresponds to this particular property or this field in this particular component.
Yeah.
So I love the fact that you could combine both some markup as well as custom code that, so that the tag actually has real meaning, and those two things are together. But, some people coming from, I think it's a XAML background, they might not like having the Dart code in the same file as the template code. And what would you suggest they do?
You can simply move the code to a separate Dart file. So what you see there is there's a script tag, essentially, that currently has an inline Dart code in it. You can switch that to put a source tag that points to a particular Dart file and move the code into your Dart.
Great.
So that will give you the benefit that if you're using it from the Dart editor or things like that, you at least get a proper syntax highlighting and code completion and things like that.
So is the Dart editor going to get better support for web components?
Oh, yes, for sure. We'll talk more about that. But yeah, the support right now is very basic, but it's something we're looking at making better.
Okay, great. So tell me how to run this on modern browsers.
Oh, it's really easy. So actually, yeah, since we're talking about the editor, so the easiest way to do this is you can go to the editor welcome page of the Dart editor. Say you just downloaded it. You're on the welcome page, and you click the to-do MVC example. And that's just a starting point. You can edit that. You can delete stuff if you don't like it. But the basic idea is there's this little file in there called build.dart. And it's really small. And if you have one of those in your project, the editor knows every time you save like an HTML file, for example, they know to run that code. And so they'll call build.dart, and it will, very quickly, order of less than half a second, update all of the things that it needs. It will run our tool that implements all these features, and then you just go into your output folder and run your HTML page. And so what we're also showing on this slide is that that same exact flow works from the command line. So you run our tool, you run Dart.js exactly like you normally would if you want to run it in a browser other than Chrome with Dartium. And yeah, that's pretty much it.
Right. So additionally, there's also, you can follow that link that we have there on the bottom on the tools, how to set things up. And one of the things we have is that we also have a Dartium extension that basically runs the compiler in an extension. It sniffs that you have a page that actually has components, and then it would actually compile it automatically. So you just save the file in your file system, refresh, and it would just work.
Wow, cool.
Yeah, we really hate waiting. Like, if you've ever seen that, there's an XKDC comic about someone that's, people are just fencing because they're waiting for their code to compile. Like, we really hate waiting for things to compile.
Yes. The C++ programmers have to wait minutes, and we're like complaining over waiting half of a second.
Yeah, exactly. So we just want to make that, you save your code, refresh it in your browser, bam, you see your changes.
That's pretty awesome.
And so you can, so what I'm showing on this slide, you can start using this now. It's a very early stage. Of course, Dart is not 1.0 yet. And if you follow the Dart project, you probably see on the mailing list there's changes still happening to some of the core libraries to try to, improve APIs and stuff. But you can start using this now. We have, this just summarizes all the features we have. And then, so where are we going, right? This is something, I think a lot of people want to know. And we really want a complete toolkit. We don't want to stop, we could give you some features. I think it's already incredibly useful, this basic layer of templating and components. But, as soon as you buy into that, you're like, oh, well, I like this, but I want more stuff. I want routing. Help me automatically serialize my objects. Help me with local storage. And so we want to keep trying to fill in all these pieces. And we would love help. But one important part of this is, as soon as you hear complete stack, you might think, oh, no, this is going to be another giant framework I have to buy into. And the answer to that is no. You can pick and choose whichever part you want. And that's very important to us because, you may have your own way of doing serialization that's different from what we think is the right thing. And so another thing I just wanted to throw out there, we got asked this. I think this alludes to one of the questions too that I saw on the list. But how does this compare to other JavaScript frameworks? Because there are a lot of them out there. And there was this great article, Thorn.js kind of compared. He picked 7 of the popular ones and went through and found, where do they agree and where do they disagree? And the agreement is good because that means there's now this set of features where, as a web developer, you can just expect them. Any good framework is going to have them. And then the points of disagreement are interesting too, because these are the things that we're still all trying to figure out, kind of collectively. And smart people have reasonable smart people have different opinions.
I disagree.
So yeah, exactly. So where do we stack up on these? So we've got, one of the big things is how you do templating, DOM for string-based. Basically the string-based people can kind of say, well, we've got these extra features like server-side rendering. And the DOM-based people say, well, we've got a better programming model. You just use HTML and you have some magic attributes. And you already saw that. We already showed you. So our templating is very similar to the DOM approach. But because we have a complete HTML5 parser, we actually can implement some of these neat features like server-side rendering. We don't have that yet, but it's something that we've been looking at. So I think on this one we might be able to get the best of both worlds. Okay. You want to talk about the flexibility?
Yeah. So I think John was mentioning earlier a little bit of this. Is it going to be a framework that you have to buy in or not? And this is one of the issues that comes up a lot in this in this comparison. And then in particular, I think we're somewhere in the middle, that we're flexible enough that we're providing a library with a lot of small pieces that you can use. So you can use the portion to use watchers to watch for changes in models, for example. But there's still some buy-in and just having to be using our compiler in order to use things today. Eventually what's happening is that a lot of these web components, in the end, are web components. So that means they're going to become essentially a tag in your system. So you can then use this tag somewhere else, and you don't have to, in that other part of your code, be using this sort of technology of web components itself. Yeah. So that's kind of like a neat trade-off.
Yeah, that's a really good point, actually. I mean, all of this is about facilitating, and then this is another point of why you put stuff in the browser. We want to make it sure that this base functionality is there, and people who are developing different components can share them. That's like, what a concept, developer sharing libraries. So I think that will be good. And then we're totally, right now we're completely server agnostic. Use this with your Rails server, use this with your Django server if you're Python, use it with, anything you want, really. We may eventually think about, people have asked us, well, what if I write my server Dart? And we may do something there, but it's just very early. We haven't really thought much about that yet, other than kind of vague ideas. But whatever we do there, we're going to keep it working with every server. And then another difference that I'll go into a little bit more on the next few slides is we have very little magic in models. Almost all of these ones, if you look at them, you have to do something a little bit special, some special controller type that you have to extend. And we're trying to keep the magic there to a minimum, so you're just using Dart classes. So I don't know if you want to talk about the data binding performance.
Sure. I mean, the part of the reason that we really wanted to keep things simple is that in the end we just want to be able to use plain Dart objects in order to write your models so that everything plays nicely with the rest of your system. And that's something that we really like to preserve. Right now we're doing things in a way that actually there is some cost associated with that, in that we have to do essentially some form of dirty checking whenever you change a model to make sure that we have to update the UI or not. later on. And the cost is sort of proportional to the number of data bindings you have on the screen. So some people worry that, well, what if I have lots of things on my screen? That would be too expensive to
thousands
of elements. So then if you do that, I mean, there are still actually opportunities to make things faster. And there are many actual directions that we're considering, and we might explore many of them. So one of them is what really needs to be on screen versus what needs to be bound. Like, there's a little bit of tension there. Is that if you have a table of 1,000 elements, most likely the 1,000 elements are not visible at once. It's more like you have a window of them visible, even though you want to render a bigger table underneath. So you can actually create smart components that know that. And typical things that or components that we've seen and done in the past have been like an infinite scrolling list, where you don't know how much data is coming and you keep scrolling and scrolling, and then you just are watching for changes on the things that are visible in a given moment. And then there are things that we can also consider. The object observed, for example, is something that's been proposed in ECMAScript 6, so that there will be more native support to observe objects, and then we can actually take advantage of that when we're compiling to JavaScript.
Exactly.
And but alternatively, since we have a compiler in the picture, so far we've been mostly processing the HTML side of things, but we can also process the Dart side of things and make classes with a special annotation, or have some special types that allow us to then make them observable and be more sort of proactive. Instead of doing dirty checking, we just know whenever something is mutated.
Yeah, and the next couple slides basically show, here's your model right now, plain Dart class. Very simple, right? If you've programmed any Dart, there's nothing surprising here. And then what does it look like with these observable annotations? And I really hope that it ends up, exactly as lightweight as this, because I think this is a good programming model.
Right.
So how do I learn?
We don't
more?
have that now, so it's a good point that to make. That's a future.
That doesn't exist yet.
Yeah, that's something we're gonna look at.
So basically, that's what we had in the presentation. Now we put up here some links at the end, and they're very discoverable. But we have an article, an explaining article with lots of examples. And if you land on that page, there are links to a more formal specification of what are the features available in our web components, a table of summary of all those features so that you can have a quick reference, and the links to our project page and our issue tracker.
Yeah, and I know Seth Ladd has been blogging some really nice blog posts about web components on his blog, and those really helped me as well. And I'm going to be coming out with a code lab, so you could learn how to build your first app. So that'll be pretty exciting. So we have a few questions. Let's go over these real quick. We have a few minutes left. So is it possible to use Google Closure Advanced Compilation on the compiled result of a Dart project with web components, or can the renaming of properties cause problems? So I would say it's not necessary. I mean, Dart is its own closure compiler. It does tree shaking and dead code removal automatically. What do you think?
Yeah, I think this might be a more general question of generally in Dart code. Like the Dart code generated from the JavaScript code that is generated by Dart.js is amenable to minification. Now, one of the things that we notice is that we have a lot of type information that is very rich in the Dart level that can be used to minify things a bit more aggressively than what you can do, for example, with a closure compiler, where you have a little bit of more of a, I guess it's less. There's a lot of similarities in the type system of both. Right? I guess there could be still similar opportunities. But
but basically, so actually they've recently added a minify option to Dart.js. I think we looked at this before. Actually, I think maybe when we came out, about a year ago with Dart publicly, that there was some problems with trying to use Closure compiler as the optimization strategy, because you're just throwing away too much information, and you have to figure it all out again. And we'll do something good in Dart.js. I think that's a much better way.
Okay, so let's say I have a bunch of content that I want indexed by a search engine. How could I use web components to present the content while still being search engine friendly?
Well, so that's definitely something that we have in our roadmap. So all the code that we're generating is right now actually essentially we have we should be able to run some of this code in the server side as well. Yeah. So basically we have a full compliant HTML5 parser that allows to then be able to process all of this and then be able to generate the actual code that you want the servers to then say, this is what my index. This is what you should index. Now, we're not trying to go to the full length of saying we're going to render in the server so that you bind the rendering in your client. The idea is just this is a separate feature just for that particular purpose.
Yes, you can basically just generate a static HTML page against, you have to make the mock model, of course, like, what's your data look like that you want the search engine to see. But you'll just be able to run it against.
And I would say that, I can neither confirm nor deny anything, but, I have seen reports on the web that say it is not safe to assume that your search engine does not understand JavaScript at all.
True.
So will it be possible to organize HTML and Dart parts of a web component into separate files? I think we answered that. Is there already a place where people share their web components, or are there plans to have a public library of common web components?
Put them on Pub.
Put them on Pub. That's a good idea.
Yeah.
Right. I mean, that's something that, just as a warning, it doesn't work today.
Okay.
But it will. It's part of our goal. So we want to make it
It's
really
an
easy to
M2
share
bug,
it.
right?
We have bugs to fix that.
It's going to happen.
Very close.
And then how do web components compare to popular Angular JS frameworks? So I know that Dimitri partially solved this earlier. Do you guys have any things to add to that from kind of a Dart perspective? How much are we inspired by the Angular JS guys?
Oh, a lot. We've already been talking to them for quite a while, and I think we're going to, basically continue that, because they just have so much experience in, real world applications that are using Angular JS, and even at scale. So I think that there's just a lot we can learn from them.
Absolutely. So is it? So what's the lifetime of a web component? Is it entirely unloaded, just removing the node from the DOM? If not, what is the best practice to manage memory with them?
That's a great question.
Yeah. So one thing that we didn't talk much today, but essentially web components have the notion of a life cycle. And currently every component has essentially three methods that are being called. There's an onCreated event, there's a inserted and remove event. And the idea is that any cleanup that you need to do is basically you should do it, or like when you're doing the remove method or the remove lifecycle method of a component. But yeah, I don't know if you want to add something about that.
Yeah, it's basically like, so if the component was created, if you're writing the component instantiation in HTML, like if you're writing a tag, especially if you put it like inside a template, then we have the capability of doing the cleanup completely automatically, and that's one of the benefits. There's nothing that you can get wrong there. If you're adding and remove, like if you're creating in code, as a limitation right now, because we can't extend actual DOM elements, you are going to have to call removed and tell us that you're removing the thing. But that's a limitation that we're going to lift pretty soon. It's just the state of things as they are now. It's basically like the state of things right now is it's going to be much more automatic and managed for you if you're able to use templates, and if you're able to keep your component instantiations in the HTML.
Okay. So I have one more question. Like, let's look out to let's look out into the distant future, because I like to try to pretend like I'm able to do that. One thing that's really good about, let's say, the Gmail client on Android is that, it synchronizes your mail, and then you could be on an airplane with no internet connection, reading and responding to email, and then when you get connection again, it sends the email. Do you think we'll get to a point in our frameworks where we have some framework concept of dealing with local storage and synchronizing with the server? And do you think that like web components and MDV are just like one step along that path?
Yeah, I think I guess there's an architectural question there, and then there's also the part of, okay, there's a lot of pieces that need to be there in order for it to work. So handling synchronization in the background and handling like offline is something that by itself is already a challenge of just how do you manipulate data from one side to the other. And then you have how do you present that data in your UI. So this is where the triangle that we talked about earlier actually comes into play really nicely, is that if you make sure that most of your UI reacts to changes in your data, then plugging in a system that is doing synchronization in the background is very easy. All you're doing is pushing those data as it changes as events, and then those events are watched by the UI, and then you have that UI being reflecting all those changes out.
Yeah.
Now, but yeah, these are things that are really exciting to work on, and I think that there's a lot of, we can even set this under this big umbrella of how do we solve all these UI problems. I think that will be one task that definitely needs to be tackled, and it would be cool to look into it.
Yeah.
Okay. Guys, thank you so much for taking the time. I know that we have a few questions left, but we're running out of time, and we'll answer those offline. Thanks again from sunny Seattle from joining. And thank you guys all for watching, and stay tuned for the next episode of Dartisans.